Okay, now this is I don't know. A lot of people like to say that nothing is perpetual or nothing can be perpetual or we can't get out more energy than we put into the fucking device to get it. But it's like that's problematic when you're looking at generating energy. Like on a mechanical basis, largely without a turbine, it's just other fucking little mechanical things. Like largely mechanically, we can't get out more energy than we put in, but we can because we can actually do gear ratios and all this other shit. Like literally, some people just don't understand the fucking sciences of what they're fucking talking about, and so we get misunderstandings. Like the second law of thermodynamics is like fucking it's a conservation or preservation of energy. So it's like everything comes to equilibrium eventually. Like unless it has an ability to keep pumping energy into the thing, yes. But it's like, well, you can't have a perpetual energy device. You can't have a perpetual motion machine. It's like, well, the thing is, back in the day, and you got to understand, it became a super novelty for some certain engineers to actually produce what are effectively perpetual energy machines. And the thing is, it doesn't put out more energy than it costs to fucking end. So you start like say a fucking like there's one that's actually a roller coaster sort of situation with the ball bearing. It doesn't have any additional kickers. It just relies on gravity and this other stuff. But that ball will get enough energy to run itself across that track nearly perpetually, as much as like if you could figure, and as much as observation is, that if it wasn't stopped, it would continue to go indefinitely until something stopped it. Now, that isn't very much helpful. Like that's just the novelty of proving that perpetual motion is possible, and it was like largely it's a gimmick. Some people just set out because like people just like the fucking it says it's impossible. Like no, it's not. Now you look at fucking the idea of like getting out more energy than you put in. We do that all the damn time. Your car puts out more energy than you put into it through the gasoline. But you say, well, that's equal in some sense. You're like, well, I guess you could say, but like. Fucking it's a translation of shit. So even if you were to say it's 1 for 1, I'd probably say it's like 2 to 3 for 1. But at the same point, it's like you would say energy. Okay, a generator cannot put out more energy than it costs to put in. It's like, yes, it does. It's like, through the mechanism of transformers, all this shit, and high transmission lines, we actually raise up the current and the voltage across all those generators through a transformer to put it on the high voltage line. There are hundreds of thousands of volts. And then we break it down when it gets to your residential area and put it to your house at 110 and 240 and all this other shit. Or whatever the fuck it is at the breaker box. But at any rate, it's like you get to this real point of, yeah, it's completely possible to have a motor, an electromagnetic motor or generator run itself. And it's a really simple process. The idea, and I've designed this twice, and there are two different things. One is a completely electrically driven one, and one is a magnetic one, which everybody's like, you can't have a fixed magnet, permanently fucking driven, fucking perpetual motor. It does not fucking work. It's like, yes, it does. And there's two concepts to this. Now, the first one, you understand, it depends on the way that the motor is designed. You don't want it horizontal. The first mistake is to make it horizontal. Now you have all your weight bearing across this entire plane, so it's creating drag even with your bearings also. It's just creating drag. So what you do is you tilt it up, right? And you make it vertical. Now, once you have it vertical, we have this other problem. It's like, well, we're still creating drags, but we're going to do something that, would make a lot of sense. We're going to put a point on the bottom of this fucking rotor. And we're going to put a polished metal dish at the very bottom, so it's going to fucking hit that. And it's going to bear all of its weight on one single point. And that's polished metal dish is going to allow it to just slip. So it's like, and then we're going to get to the next point. So we have that rotor standing up. Your ball bearings, we don't want. We want a magnetic collar of one polarity affixed to that rotor at each point that we want bearings. And then we want a magnetic collar of the opposite polarity over it, shrouding it with a little gappage. And then we want to fill that with ferrofluid. Now, the thing about ferrofluid is it creates, like, when it has a magnet applied to it, you apply that ferrofluid to the magnet, like you slip it across paper, it has, like, zero slip. I mean, zero traction, or like a zero friction. So the same thing in this, because now you have that polarity thing, or you want to make them with the same polarity, so they're always repulsive. There we go. That's actually what I meant. The same polarity, but they're repulsive. But the thing is, the ferrofluid will sit in between it as a cushioning gel, and so that thing will just sit there. It'll have a full slippage, and it'll always push that rotor into the center of that ring. So it'll always have the slippage, and it'll always have that buffer, and it'll always have that fucking thing pushing it. It's just keeping it steady in the center, and so you don't need the bearings to create drag and all this other shit. So now we do going up this rotor, we can have a number of stators, and they can be as close as you want them together. They make sense for them to be so. But in the middle, what we're doing is we're going to make a brushless motor, in a sense. So we're going to put down this fucking rotor. We're going to put, these magnets in there in the midst of the stator. So the stator is really like a couple inches thick, and it's got its windings for like DC, because DC is safe because you're going to put it in your home. But DC, even at high voltage, it's a zap, and it's like, hey, the motherfucker doesn't surprise you, but it won't fucking kill you. So you can put as many stators now you want in there with your windings and all that shit. Now, the next trick is we're going to fucking hook them up with an LC pump between every one of them, make them resonant, and along with a diode, make them resonantly linked to one another. So you're going to build up, through induction and capacitance, a higher voltage and current. So this, you're like, well, where's the perpetual fucking portion of this coming? It's like, okay, well, let's finish this first. Now, at the very end of this shit, we're going to put it through a transformer. And, it's another series of capacitors and resistors for our resistor capacitor network. But we're going to raise the voltage out at the other end to be a higher voltage to the transformer. And we're going to get that windings through the induction is going to do that. But now to get it to run itself, okay, first we need a kickstart battery or a kickstart source. And we're going to have a circuit that says, when like a relay that's going to shut the battery off when it meets a certain fucking voltage. So what's going to happen? We have a motor running it. And then we can say, well, the motor needs energy. Like, yes, okay, that's fine. But on that first fucking couple of stators, we're going to put a joule thief on there. And we're resonating. We're building resonant energy. So we're building current and voltage through that LC pump and the fucking joule thief. And we're going to pass it back into the motor, into that relay. And because it's building up that conduction, it's building up that fucking resonant conduction for the fucking, for the current and for the voltage, it's eventually going to open that relay, and it's going to shut the battery off, and it's going to drive the motor. And that's simple enough, because we do this shit all the time. If you think about it, if you just build an appropriate joule thief for it, it takes a little bit of voltage, a little bit of current, and it amplifies it. Basically, the way I've always understood, the way I've looked at it, is like you have a little coin cell battery that's about to go dead, and that's 1.5 volts. You have an LED that has a forward voltage of 3 volts. And you put it on there, like, that battery should die within fucking, like, if it had little charge, that light should not stay on for very long, because you're already not able to light that light with that battery. So if you're not killing that battery faster, you have to understand, then think about where you're getting this energy from induction, because it's not ultimately coming from the battery. So what happens is you're building a field in your inductor, and you're building this field, so you've got to be attracting shit. Now, we already got electrons in the wire, and it's bouncing back and forth. It's building this attraction. It's like, what's going to happen? You're going to gather electrons along the outside of the wire. And so those are going to get moving. And so it's going to build up to the strength of that field in your inductor, and then eventually when it goes to release the shit, it's going to pass it along to the fucking least point of least resistance with the solder point in your joule thief, and the circuit is going to pass it forward. It's going to go on. So you're not really fucking seemingly getting anything out of the battery any more extra than you are. You're getting it out of the atmosphere. You're just getting a little bit of charge to be able to do that. So it'll drive itself. And now with the permanent fixed magnet shit, your geometries are absolutely important, and I figured this out. And it's a little novelty toy that fucking, kind of fucking reinforces it. There's a theory that I already had, is like, to some degree, like geometries. And it's like fucking, why would it be hard? So what it comes down to is the faces, or the geometries, the shapes and the sizes of the magnets, ultimately. Like, to do this, you have a fixed magnet on one end, and on your rotor, you'd have another fixed magnet. And it will work. And so what happens is, like, you take that fucking, that rotor that we've just built, and we're going to take the top off, and we're not going to have a motor on it. We're going to stick this cube magnet on there. And so it's going to be like neodymium or fucking, rare earth or whatever it is, as long as it has, polarity on its sides and they shift. And it doesn't need to be a particularly strong one. It just needs to have enough of a strength that it has an attractive and repulsive force. And now the fixed magnet we're going to use to drive the thing is going to look like a bar magnet. It's going to be, fairly wide. But even then, in the better sports of this, like, it should be several thinner bar magnets placed together so it has an additive force. And it's going to be more additive than the original bar magnet. If it was of a certain size or the same size, it would actually be stronger than that one because it's an additive force, and so it builds up. But it has to be wider than that cube. And it has to be stronger than that cube. So what happens is the cube still has an attractive force to that fucking bar magnet. But the thing is, by the time it hits this point at that angle, the next face is coming. You're hitting the corner of it. So now the bar magnet wants to be repulsive, because it swings it so fast, because that bar magnet is stronger, so it's going to swing it. And so you just start spinning the motherfucker. And since it has no place to go, so let me tell you about the fucking toy. So the toy was this little ballerina. So it's a ballerina on this little sort of top thing. And it has a mirror that goes along with it. The trick of it, it's a novelty toy that, when the ballerina sees herself in the mirror, she wants to dance. And so the thing is, like saw this, and I fucking saw that, and it starts spinning around, but when it gets out of phase of the fucking magnet that in the mirror, it stops and it wobbles, and it fucking just stops spinning. So I automatically concluded, like, okay, well, there's obviously trick to this, it's obviously magnet, so like what it is, but it still spins. So whatever the fuck it is, it's a geometry thing, and you notice it'll keep spinning as long as the fucking plane of that magnet is not out of alignment, it's not out of phase with it. So if you were to stick it in the corner, or fucking stick it on a pedestal or on a string, it would just spin the fuck around if it was just fixed in a place. And so, like, the dude opens it up. The dude has a patent for the novelty toy, but not for the purpose that I'm talking about. But even then, what I'm talking about, I'm recently a two-part license. Like, one is a open source license for non-commercial use, and the commercial use would actually be negotiated to me to the sums of understanding what the quantity is and be setting a final price that you'd be allowed to charge, because this shit costs next to nothing to do. And I don't want people charging $1 billion for the fucking. You basically get in there, and I'm fucking putting it out there to the fucking, like, this is my application to the shit. Each one of both of them, and I don't want to see a bunch of people going out there fucking charging a bunch of money, because I'm just going to throw the information out there for free, and you're not going to. Whether the fucking the license already now applied to my fucking video and all this other shit, and the copyright applies. The license is legally valid because I'm going to tell you what it is. I'm going to put a link to the fucking thing and include it in my fucking my description, all this other shit. For it is, like, all things will have to be negotiated for a commercial rate to actually build them for a commercial purpose to sell them. Otherwise, the open source allows you to build them for yourselves, and even then recoup money for materials and installation and shit like that, but not to make a profit. Ultimately, at the end of the day, so it's like it is the same thing as that other one. It's just like it just uses magnets, and it's not nearly perpetual, but it's perpetual enough that, like, those magnets have the strength that even then you can just hot swap them when they need to be and build several of them. These things are just so fucking cheap to build. They're literally, less than $100 or so. You got this generator to go, and literally you could probably just take the fucking transformer out of a microwave. Like, you recoup a microwave and get a transformer from there to just ramp up your voltage and shit off that fucking generator, or several generator. Because what I would consider is you put it inside of an iron tube or something, and then just balance it off in there. So you could 3D print, your stators to route your windings and shit. Like put those in there and stack them in there, just like way deep, and just pass this wire down. And brushless is the best way to go. So none of those parts wear out. Except for that motor and the one fucking safe, but that motor's going to run for a long fucking time. But the magnets are going to, like, there's no wearable parts really, so much. Like, they'll last. There was something else. Like, you could actually make a similar situation with that nickel platinum wire, whatever the fuck it is, like the one that flexes with the temperature gradient. Literally, you could use that in a dish of water. You make a loop of that around a fucking a rotor, a fucking spindle. It'll just fucking flex and fucking release, and it'll fucking spin that thing, and that'll run a rotor. It'll run it really slowly, but all the same, it'll run it. That is perpetual for as long as you can keep that dish filled with water, or you can allow it to pass that fucking through that water. So as long as it cools and heats up, like, literally just the temperature gradient in the room is sufficient to get it to run. So some things, God puts these little fucking tricks out there. And it's like, to go out there and to kind of find them is like a strange little thing. Is like, I was actually messing with this idea for a little while back, and even then I had the idea because you can magnetize anything steel that has iron content in it. And I found out, like, apparently God would not let me fucking magnetize a steel ball bearing, even though the magnet would attach to it, like all this other shit. Like, I could magnetize a screwdriver with the same composition and all this other shit, but I could not magnetize a steel ball bearing by the same means. And the idea was that I was going to stick, that was going to be my driving force. It was going to go through these partial ring magnets, because it would just go through there like a fucking track, where the magnets would act as a Gauss cannon, so it would attract the fucking bearing and it would shoot it out. But even then, without the balls being magnetized, that could actually work still, because the balls would be attracted to the magnet, and because they're spaced out logarithmically, and then the amount of arms that it would have on the fucking rotor, with each attached with a fucking a brazed or soldered ball bearing, like, you would, by the time you get to the end of the track or the end of the fucking Gauss gun, for it to track the ball bearing, it would be sucking in the next one to cause it to run. So that one's completely perpetual. I mean, as far as as much as long the magnets last, but whatever it is. But at the same time, you could literally, I guess you could use fairly weak, electromagnetic motors and run it off fucking the same thing, a joule thief to the stators, to the coils, and back to the fucking thing to fucking, attract the the ball bearing, and then like make sure that each one only fires for so long based on using a sensor. And since, it takes very little power to fucking power the sensor, like literally it's just going to be like a light sensor. Like you're going to use a photovoltaic, resistor. And if the light changes a little bit, fluctuates, you're going to be like, oh shit, I need to fucking activate this one now. And then so it'll deactivate the last one, activate the next one. It only was so long to operate the damn thing. And so like, you could probably make that pretty easy. The stuff is, in my understanding, like not difficult. But it's like maybe things that people already knew, but even then some things that people just don't think about. And I've had this consideration for 0-point energy, and I don't know how this would actually work necessarily, but the idea of a full bridge rectifier that has a power that's taking power from because normally you would take AC, pass it through it, and it chops it, then makes a DC signal out of it. But then applying what this is, instead of doing AC, you're doing DC, but you're applying a positive power rail and a negative power rail. But the configuration of where it falls on those diodes is important. So it's like what it is. You have your positive, your positive negative rail, which is your positive rail with your negative pole, and your positive rail with your positive pole diagonally from each other on if you were building it as a square or whatever the fuck, in like your diagrams it would look like when they show you what a full bridge rectifier looks. You put them diagonally to each other, and you put them in those appropriate places, obviously. So you put your positive behind the line, or behind the little line on the diode, and you put diagonally across from that, you put your positive negative in front of that line, and then your negative, you'd actually put down at the bottom on the left hand side, and your positive negative on the right hand side top. Negative positive on the up hand side for what it is. So basically it's just going to loop it around. So now you have it's not a shorted circuit. Literally you use the same fucking power supply to do it, the same power source of like the battery, what it is. But it shouldn't short based on the way the direction that it flows. It should actually create a zero voltage. Technically is fucking like maybe just like my electrical engineering theory is like this is a little screwed up, it's a little weird. Because now you have a positive or negative, so it actually so instead of like moving electrons in any given direction, because it can't, like it literally moves them, it just jiggles the fuck out of them. It builds a field in the circuit instead, based on the arrangement of the diodes. And so then you tap the fucking full bridge rectifiers somewhere in the middle on either end to get your voltage out. So literally it provides a voltage equal to the voltage you apply, but it's actually technically a zero voltage on it, but it has current to it. So you have current flowing from both positive and negative into the circuit, and it's chopped to where it's supposed to be and flowing to the places it's supposed to be flowing. But it just jiggles the fuck out of the electrons because they don't know which way to go. So you just built a field from both ends. So you have a positive field and a negative field, so it just becomes neutrally. So this is your preservation of energy, your conservation of energy, because now nothing goes anywhere because it doesn't know where to go. So it just jiggles the fuck out of these things erratically. These electrons in their fields are like, it wants to kick one over here, it wants to kick one over there, but it doesn't know where to kick it, so it just jiggles the fuck out of both of them. They just fucking mosh pit around, bouncing into one another. So it's not AC, it's still DC. It just doesn't go anywhere, so you just build a field in the circuit, and now just fucking... And this thing, they're like, well, that can't be perpetual like that. Yeah, that can be. As long as there's fucking energy in it, it can't go anywhere. It doesn't know where to go. It'll just jiggle the fuck out of itself. You're not going to lose energy, except for, you say in heat if you don't recoup it, but it's like you can control the flow of just how much current is going through that by the resistance of those things. And so, like you say, you pass it through, the electrons aren't going to pass through the light bulb, but it's going to excite the filament in the light bulb. Well, the photons can out, so they're like, but we're passing out energy. No, we're not. We are, but it's not electrons. We're passing out photons. We created a new energy from our old energy, which is just staying put in the fucking damn element. And we're passing out photons. Now, if we collect the photons, we can actually take the energy back and put it back into the system, or put it into another system, depending on our photovoltaic, cell, which is like the calculator cells from Texas Instruments or whatever. It's like they're using cheaper calculators now. The really low voltage ones put out like 1.5 volts and some low current, and they're more efficient than you think about. A lot of these fucking higher efficiency ones, but they're so specific about the amount of light or the kind of light or how directional the light is, the angle of the light that they take in, that they're not actually fully efficient, especially if you're using a really shittily designed power management circuit. So it's like it gets to be real bad. So it gets to be like I see these fucking little battery packs, and then we're gonna get into the fucking same thing. It's like fucking this. I'm gonna put this on here. Fucking this. It's the same thing with the rest of the other shit. Open source for as much as like you want to make it for your damn self, and make it for a friend. But like if you want a commercial, make this a commercially viable product, you're gonna have to contact me, and we're gonna have to negotiate some shit. It's like my phone number or my email address is John Fink. The I is a 1, and then it's 1337@gmail.com, or my phone number is 918-703-1592. And my name's Johnny. John Fink, for the matter it is, or they actually Jonathan Salinas. I was just like, I think about it. So what you do is you take those calculators and you just bop the fucking solar cells. You can probably buy the solar cells for like fucking 5 cents a piece or whatever, fucking from China. And wire them in, put a jolt, you fucking amp up that current a little bit, and fucking apply it to those fucking solar cells. Because this solar cells, like, if it doesn't have a particular amount of charge, it won't charge. If it's not getting direct light and fucking this other shit, and don't put it in the sun. I'm like, that sounds dangerous as shit. Literally, fucking this shouldn't have a solar power on the batteries. You should have a little panel that plugs into it. And you set the little battery pack off in the shade. You set the solar panel out in the sun. But even then, with these low light sensors, it'll fucking charge under the moon. It'll charge under your lamp. It doesn't care what kind of light it is. If you light a lighter next to the damn thing, it's going to start charging. So like, there's these little device things, little quirk things. It's like, why do you design the things that you do the way it is? And I know it's cheap for you to make it that way, but it'd be cheaper for you to make it this way. And you can make the same money off of it, because these little battery packs that have the solar cell on them only cost fucking $20 to put it at the end of the day. What if it's just like a photovoltaic resistor? It's like, well, we just know the sun's charging on it, but we're actually not going to charge shit on here. We're just going to say it doesn't charge very well, blah, blah, blah. Well, we just sold you a battery pack for $20, whatever. With the false belief that, it's actually going to charge under the sun or something. But he's like, at least it's a battery pack that fucking holds a charge, even if it doesn't charge by the sun. Because it seems like it's such a strange cop-out that if it doesn't have enough voltage on the battery pack, it's not going to charge under the sun. I've left this motherfucker out in the sun fucking all damn day, and it didn't charge. Like, almost no matter what. Or even at, like, barely trickle charge. I had to fucking add another one of these, like, cheapo fucking 5-watt or some shit solar powered USB charger things to it. Like, it just barely trickle charged. And it's like, it was facing the sun the entire fucking day at an appropriately decent angle. And it makes no sense. But anyways, that's about as much as I have to say about this stuff. At least at the moment. And I got stuff to say about other things, and I'll get into that, some other time. But if you're interested in any of those things, like as a commercially viable product, or even if you don't believe it, go try it out. If you have problems getting it worked out, maybe you just need to tinker with your setup, your system, for some shit, because I know it works. And it's like, this is like all there is to it. It's like, it's simple, easy energy, and like literally you could just, for $100, you could build a couple of these damn things, wire them together, and have power for your house. And even then, your power company, you can backfeed, get an electricity wired into your system and backfeed, and fucking get a deal with your electrical company to get credited. So you don't have an electrical bill, and at the same time, you're going to generate money off of it, because, well, you're going to generate credits. Let's put it this way. The power company does not want to fucking pay you. They don't want to give you actual money. They're going to give you credit. And at some point, you're going to have to amass so much credit. If you fucking produce this fucking time, and what it is like, they're going to have to give you credit. It's like, let me go ahead and get to this point. Everybody's buying these, like, 3.4 volt Li-ion fucking cylinder fucking battery pack, whatever the fuck it is. And they're fairly cheap or whatever. They have so much milliamp hours, so like, because they're measured for small device practices and all. But you know what's actually a really cheap solution to this? These 6 and 7 amp hour batteries that are meant for like deer fucking feeders and these ride-on Power Wheel toys and shit like that, because they're 6 volts. So you can wire the 2 in series and then wire a bunch in parallel to get up your current. And they're only like 6 of these things cost $50. And that's not bad. It's like, even on the lowest end, it's 4 amp hours per battery. That's pretty good. Even though it's like you're saying, well, that you're saying it's only 4,800 amp hours of batteries. Like, these are meant for large applications. So really, when you break it down, it's like, for the application, these are much larger cell batteries. And they do, so like you look at a 4 amp hour batteries, like your mini fridge or whatever the hell may run at an amp. It'll run that fridge for around about 4 hours. So your little small applications, your little motor, it's going to run that motherfucker a really long time. It's usually, well, 48 milliamp hours, like, or 4,800 milliamp hours, like, well, what's the draw of your motor? Like, if it'll run the fucking fridge for about 4 hours or fucking 3 hours or whatever the fuck it is, and it'll run that motor for fucking, I don't know, 12, it'll run a long time. It just matters, because the math is always getting weird. It's like, sometimes like what it is. Like, some numbers may be misrepresented in such strange ways, but it's like, you look at the base of the application, it's like, you're looking at little applications differently, you're looking at big applications, and the milliamp shit somehow gets confusing. Like, I ran a 12 volt motor on a 7.4 volt battery for hours. And it's like, and if it was a full blast, now if it was running the rest of the shit, and even then what it is, it should have only ran for several hours, and even then it really should have only ran for like 1 hour or 2 hours at most. So it's like, it gets really strange in these applications and some of these things, like that milliamps is like, really you have to get in there with the damn multimeter to see what your real draw is and all this other shit. But it's like, it gets simple to fucking look at your application, just look at the milliamp, or the amp hours, just like, just go by that. If I got 1 amp for draw, then I'm round about 7 hours for the operation. Like, I'd probably say 6. I mean, unless you really got optimal everything out of it, and you're not having a lot of loss and all this other shit go on. But at any rate, they're fucking cheaper to stack, and they're safer to stack than those Li-ion cell batteries where you're fucking trying to, tack weld this shit. These just take terminals that you plug in, that you can primp and make and fucking plug onto them. It's like so simple to do that, and they get a fucking DC power regulator, a DC to DC power regulator, power supply regulator to turn it down, and put that out to an inverter or an inverter board, or like a big one or a little one, and then put a charging circuit on it that's set to, a little higher than your current draw, because then you can trickle charge it at the same time with solar cells and all this other shit, and do it that way. But anyways, yeah, that's enough. That's a safer way to do it. That's the cheapest way that I could think to do it, and the safest way. But even then, I would tell people to use dry cells, because lithium is so volatile, it's so unsafe, especially fucking like for shortages and shit. Once one fucking blows, like, it's dangerous. They're highly volatile. I used to work in the oil field industry. It's like, if we had a leaky battery, I don't know why the fuck we're using lithium, other than the fact that it was retarded, but at the same time, so is alkaline. Alkaline's completely retarded. You can buy alkaline batteries off the fucking rack. If you got a charger, you can stick them in there, because it'll tell the fucking battery charger to cut it off when it gets to a certain fucking current rating and shit. So it's like, you can recharge current alkaline batteries. You always could. It's just rechargeable alkaline batteries have a slightly better chemistry that allows them to recharge more. But you can recharge any alkaline battery. You can recharge any dry cell batteries, and it's cheaper to go that way, and it's less safe. If they leak battery acid, it's not going to blow your fucking house up and set your house on fire and kill you and your family. But anyways, that's all I got to say, so I'll check you next time.